My name is João. My handle in the scene is Anticore. This is liqube.
I'm Tom. Nice to meet you.
And we're here to talk today about Cables.gl as a demo making tool. So who am I? I've been a scener since 2020, originally lurking in the Revision Twitch channel. A guy called Genio found me there and took me to the PS Discord, and that's where they convinced me to do my first demo. After that, PS convinced me to start doing some shades. This PS convinced me to do everything, to do some shader live coding. Did that for a while, some shader showdown stuff, and then I decided that I wanted to start making demos. So at this point, I was convinced that the best thing to do was to create my own engine from scratch, because it seemed to me that's what everyone in the demo scene thought was the best idea. So I started working on that and failed completely. It was a huge time sink, but also that was good because that's when I found Cables, our Lord and Savior. And who is liqube?
That's me. I'm the other guy. I also do music.
Yes.
I think that's enough. It's his seminar. I'm just support, okay?
So what is Cables.gl? So Cables.gl can be defined many different ways, but probably the most accurate is it's a node-based web development environment and tool based completely in the browser. So this screenshot you see here is a screenshot of your usual development environment within Cables. I can show a bit of that later. So basically, you use these nodes that are called ops in Cables, and you connect them with yellow cables that mean execution, so they control execution, and then the other cable colors are values. So that's how you connect everything visually to create your programs. It's mainly focused on WebGL applications, but it can be used to do more traditional stuff and other stuff that I'll show later. It was created by Panduran's team from Undev Studio in Berlin, Germany. They're also sceners, so Cables.gl has a lot of cool things for the demo scene, thanks to that. And at this point, it has more than 23,000 registered users. Good things about Cables. It is very easy to learn if you have some time. Mainly because it has a lot of YouTube content created over the years by the devs and also users that decided to create this content. And so this talk will not be like a straight-up tutorial on how to use Cables, because there's a lot of that content already online. I'll try to do more like a showing of how Cables can be used to make demos, and later, if you want, you can look at other YouTube content. I'll show it a bit here. So this is Cables.gl YouTube page, and you can see some of their playlists. Let me see, for example, bite-sized tutorials, for example, is a playlist of tutorials that are very short in time, and from this you can learn a variety of effects that you can later use to do your stuff. But also, if you go to Cables.gl main page, which is cables.gl, you have here a menu entry that contains all the documentation in Cables, and Cables is well documented. You can get a list of all the nodes you can use, and mostly each node has information about inputs and outputs, and has an example that you can open and check out how to use each node in detail.
I have to add something though. You should definitely, like, I was new to Cables. Like, I was introduced to it by Anticore, and you should definitely try to open up existing demos, even if it's small ones, and try to look at how a certain effect works in that demo. So like, instead, like, the examples are good, but when you drop into it, you think like, okay, I connect nodes. It's not that straightforward because some go up, some go down. It's not like everything flows in one direction. So it's good to just look at the demo and go like, okay, there's a scroll line there. I want to do this.
And for that you can there is this menu here, Explore, where Cables users. So basically to develop, you create an account in Cables.gl, and you have your editor, and you can save your patches to your account, and later you can make them public.
Sorry, Anticore, do the echo chamber.
Okay.
You can do the echo chamber, and that's a flyer for a set on Sunday.
So this is a flyer I created for the live performance that we're gonna have on Sunday. This computer is a bit slow, but it was made in Cable. So basically what I was trying to say is that you have this list of public patches that you can access, choose one, and then you can open it in editor and see the full code for each patch, so you can learn what each patch does and how it. This one is not a very good example, it's very messy, but yeah.
Well, the point being is that you have something that you can look at. You already know how it looks, the final product. So you're like, okay, I want this. Like, how does this work? And then you just jump into an existing production and look at how things
the
are
code
done.
is there. Yep.
So, and even though it's messy, the flow is still the same.
Yes.
The concept is the same. So this is a good way to learn Cables.
Yep.
It's better than just looking at examples because they are very disjointed all over the place.
Yeah. So I can also show here, just to set everything up, a basic example. This is a patch I created just for this seminar. So here you can see a very simple Cables patch. So like I said before, all the flow is controlled by these yellow cables, which mean execution. They're called triggers. Here the main loop node, main loop op, is every patch uses this op. That is what gives the animation loop that runs every frame, right? So we open this, we create this op in the patch. It starts the canvas and starts triggering this output every frame. We pass this output to a sequence, and what this sequence node does is that every time this is triggered, it goes to this trigger's outputs, and it goes trigger this, trigger this, trigger this, trigger this, etc. So this is how you can place objects sequentially. So basically, if you had two-dimensional objects and you want to place one in front of the other, you would trigger the second one after the first one. Yeah. So this is basically how Cables patches are constructed. So here, for this example, I have a cube op, which is that cube mesh there. I apply a Phong material to it, and I transform its position. One thing that is usually confusing for Cables novices is the order of execution, because, for example, here, main loop executes this sequence, which executes these ops here, but then transform applies to whatever is below it, and Phong material applies to whatever is below it. So sometimes the order of or how each op behaves in relation to other ops is not related to the execution order, but has some other logic behind it, and that's just you gather that knowledge with experience. But moving on. So, like I showed here, I showed two default ops, the basic ones, but there's a big collection of other default ops. So, in any patch that you're editing, if you enter the tab key, you get the list of ops. Here on the right side, you have a category of ops. So, for example, if I wanted to check out what texture effects Cables can do, I can just go here to the texture effects category, and you can see all the ops that are in that category, and there are a lot over the years. And then if you want to use one, you can click it to check the documentation on the right side, view documentation, and then when you open the documentation, you can see here the example patch. And so by using Cables and by experimenting in Cables, you can also discover new ops and learn this way.
I have to add something though. Like when because there are so many operations in cables. Scrolling through the list, like for me, was incredibly confusing because where do you even start? And that's why I meant, you open an existing demo, you see which ops are interesting to you, and then you read into how they function.
Yep.
This is the best way to do it. Don't get overwhelmed by scrolling over it because it's too much. It's way too much.
Okay, so apart from all these default ops, there is also the possibility to create custom ops. So basically, if Cables doesn't already do something that you want it to do, you can program it like any other JavaScript application and control whatever you want to control in the browser, and use the Cables API that they provide to create ops that interact with Cables and do whatever you want. So
and
basically, from within a custom op, I don't think I can show it very easily here, but maybe if I open one of my custom ops.
But the custom ops are programmed in JavaScript.
Yeah.
That should be mentioned because everything runs in a browser. All of Cables runs in a browser, self-contained. It's JavaScript based, so that also means when you create custom ops, they run on JavaScript. And it's very easy to, like, if you're used to JavaScript a bit, it's very easy to like extend it into anything you want. And we're going to talk about that a bit later, about a really big thing that we made for the last demo.
Yeah, so here's an example of a custom op I created a long time ago, but this is an example of how it can interact with Cables. So this object you see here, op, is an object that Cables provides, and it has all the information about that op you are programming. So with it, there's methods to create inputs and outputs. So here I'm creating an input trigger, an input boolean, an input trigger button, which is kind of the same as a trigger. And so then I'm creating all these inputs and outputs. And you see, as I created them, they appear here in my op. So if I wanted to add another input here.
So when you look at this, the inputs are usually on the module at the top, the outputs are at the bottom. So you see by the color, what type they are. You can explain that, what type they are.
So green is a numeric value, like a boolean or number, and then yellow is execution, like triggers. So now I've added this line to create a new number input, and you'll see next to the green one, maybe, a new one will appear. Maybe.
So what you can do with this is you create basically outputs that are analog, inputs that are analog. You can have outputs that are digital, like just triggers, on off, and you can process that accordingly. And yeah, that's one way of doing it.
It's not in number, it's in floats, I think.
And of course, when you hover these, when you hover these outputs and inputs, you'll see what they are. That you should probably show because it correlates with the description, the label.
Sorry.
No, it correlates when you hover the inputs and outputs. You see what they are.
Yeah, they show this label here, and then I can get at any point in the execution, I can get their value, set their value, everything. So this here is just an op that loops the timeline. So it gets this input of whether it's active or not, the time start and the time end, and then I can trigger it to set the time start and to set the time end, and then basically just loops the timeline between those two values.
You can basically do everything that you can do in like signal processing. You can put an oscilloscope at the end of an analog output and just see what happens, if something is happening or what is happening and how the curve is going.
We'll show some more custom ops as we go on. So Cables.gl is also suited for the demo scene. A lot of demos have already been released with it. It's made by seniors. It's used by second place, I think, revision last revision was made in Cables. So it's tested in the battlefield that it's a good demo engine. But it's also used not only for the demo scene, but for other types of projects. From traditional web development to more like interesting web experiences to this screenshot we have here of a physical installation where the graphics were done with Cables. And also carrying on from the custom ops, if your custom op is something that doesn't exist in Cables and it proves to be useful, the devs will also have no problem including it in Cables as a default op. So here we have the example of the physically based rendering shader created by a Majestic C Flap Flap. It was created by him as a user, and since Cables didn't have a PBR shader before, it was added as a default op, and now you can use it straight from the default op list. And here we have another screenshot of the physical installation. This one is, I think it was for Google, if I'm not mistaken. It's called Cube. It's by Dr. Kurel Benzi and Eduardo Maluf de Campos. They're both Cables users, and you might know Eduardo as Baguf. So, carrying on from all this, it's a very active community. It's full of users that are just starting, others that are more experienced, some that have a lot of years in the demo scene, and they're all very accessible, happy to share their knowledge. There's a Discord server just for Cables.gl where you can ask all the questions, get answers very quickly. There's also regular meetups where people talk about what they're working on, interesting stuff. The devs talk about the future of Cables. And as I've been saying, the devs are also very involved with the community. There's already a GitHub for you to submit issues that they can fix. You can bug them on Discord like we all do, but be careful. And also, they have plans to make it open source, so very soon everyone can contribute and improve it. So, Gaia Space Agency, that's the name of our demo group. We have released 4 demos so far with Cables. Started in 2021, Inércia. And so I'm not an expert by any means in Cables, but I have learned this and I have a few stories to tell about it. So this is not as much of a tutorial, it's more about some cool things you can do with Cables. So now we'll quickly show a demo before talking about it. That's okay?
So that's your first Cables demo, is it?
Yes, this is the first Cables demo, so I'll talk a bit about it later, after watching. Sorry. I'm sorry about playing this off YouTube. Is that? Quick before the jazz? Okay. So that was the first demo we made in Cables. Like I said before, I did mostly shader stuff and tried to make an engine and it failed. So this was the way I could actually get down and make a demo is by having something that allowed me to do shader coding, but also have those little things that make a demo like time syncing and generating textures and stuff like that. So that's why I started using Cables. Cables allows you to pretty much function as a glue between several fragment shaders. So this is what I did here. Every 3D scene you see there, with exception of the initial logo and the credits little screen. The grids little screen is generated as by a ray marcher, and they're each different shaders, and then there's just like a little time sink to change the scenes, and everything else is done within the shader, because that's what I knew how to do at the time. So Cables allows you to have a custom shader. You can program it like you usually do in GLSL. I can show that here. So let me see if I can do a quick example of this. So in Cables, there's this op called Custom Shader. That allows you to write a fragment code and a vertex code. It has it is GLSL, but it has a little bit of a custom syntax. But basically, you can mostly ignore these lines here. And the most important lines are these ones on top and whatever GLSL code you have here. But these ones on top, if you write uni float number, you are creating a float uniform. So basically in GLSL is usually like this, right? But in Cables you write it like this, and when you save, save, sorry, something is going wrong here. Well, maybe I'm not remembering the syntax right, but you can create uniform input ports on the fly on your custom shaders, and really quickly create new uniforms in your shader and pass the value straight up. So
so what this basically...
I can open a different one.
What this basically would do is that you have your shader, but you can kind of like control the visuals with anything that Cables provides, which makes it really powerful. So not just can you create your own code, like functional code, but you can create your own shader code and, well, have like controls over it. You add visual controls on screen, in the preview window, or you just control them from a trigger from something else. Yep. So
I'm opening here the project of the demo. Make the preview smaller. So if I go into one of these scenes here, so each one of these is a sub-patch, which means it's a patch within the main patch. So here I have one sub-patch for each scene. So if I go into here, the intro scene, which is the icosahedron, you can see here that somewhere around here there's a custom shader here. And if you open its code, you can see that this is the code that generates that whole scene, and it's just a ray marcher basically. And here you see I'm not sure why this wasn't working, but here you see the creation of the uniforms. So I'm creating a uniform for time, resolution, some textures, and it automatically creates the ports here in the custom shader op, and I can straight up pass it the values and automate the values with Cables, and it's just there in the shader automatically. So it's like a shader toy where you can program any input at any time. So in this demo I use this just for simple animation, positions and stuff, but also to create like noise textures. So I didn't have to create them in the shader, I created them outside really quick, and I moved on. So yeah, also on the realm of custom ops for this demo, I tried initially to use Cables timeline. So Cables has a default timeline for syncing your animations. But I found it very difficult to work with my workflow, so I decided to create a custom operation to basically use a different timeline, and the one I used is by Observer, and it's called Automaton. And it's just a timeline editor. That uses Bezier curves to animate each parameter. And so if I open here the project of my patch, I open here in the editor, it should open Automaton here. See, here it is. So this one doesn't have a lot of parameters, but I created this custom op here called Automaton. And what it does is just, it loads the JavaScript file, it imports it into the page, it creates a new tab here. You can, using the Cables API, control the UI of Cables. So I created a new tab in Cables, injected Automaton, and from there on I created another custom op called Automaton channel that can go and read a value from Automaton. So here I can do my animation stuff, and then it comes out here in these values to either other ops or to my shaders as uniforms and stuff. Yeah. So using the custom ops, I was able to create my own timeline implementation and use that. Here is a screenshot of the custom shader that I spent a lot of time showing. And there is a, yeah. Okay, second demo.
Com a Glovo podes pedir o que...
This is a song I wrote. It's a song about feeling alone in a world of polygons and vectors. Hope it's not too bad.
My body's made of sand and wire. I had no dream and no desire, and still inside I feel a dire grief. I shade reality to find relief. I can't feel it kicks all emotions. I feel I'm going through the motions. But if my GPU is strong, I'll find the place where I belong. My uniforms are RGB. It does not mean nothing to me. My execution never seems to end, and all these members that I call my friends, they never hold some sort of meaning. What is this strange thing that I'm feeling? I hope I'll return in the end. A value you will understand.
Thank you for watching my demo. I am grateful for this moment with you. Now you will leave and forget. It's okay. I'll keep on computing these colors. Before you go, I wish to extend my warmest respect to the motherboards and processing units of Alcatraz, Lunis, Altair, Prism B, Still, New Sand, T-Pom, Logicoma, The Black Lotus, Yos, Observer, Evil, Pooh Brain, Far Broush, Unbound Design, Cool, Ninja Devil, Satori, Bass Pigs, Epic, Spectrals, Coolers, MFX, Conspiracy. All those named no more. All those yet to be named. Goodbye.
Okay, so moving on. So yeah, this was a continuation of using automaton as the animation, but also trying to move away for the first time from the shader stuff. So the process for this demo was actually a lot like I said in the beginning of just opening the ops list and finding random stuff. For example, the grids part where the text shifted, I actually found this op randomly called the line font, which renders that the text that way, and it's just a collection of splines of lines that do that. So then you can manipulate it as a mesh. And so I spent some time doing some experiments of morphing that text, and got in some problems with that. Joined the Cables meetup, talked with the devs. They helped me understand what that op did, and I was able to include it in this demo. So it's a really cool way of discovering their work from the past, of stuff they did in the past, and then trying to iterate over it. And they are super helpful, and they're always willing to play along. So here, for this demo, there's two audio tracks. There's a music and voice audio track, and there's a just voice audio track, and that's used to generate the waveform that you see in the beginning. And yeah, that demo was pretty much it.
You should mention though the starship, the starship on the previous slide.
Oh yeah, that was the first time that the starship appeared. No, that was the second time actually. It was
It's the
on the logo
second time.
before.
Yeah, it's like kind of like a brand.
That's the first branding, yes, of Gaia Space Agency.
Yes. I hate YouTube.
と一緒に踊りたいだけです私は愛が欲しいだけの女の子です私は自分自身を失っています私はあなたに恋をしている
No. Trust me, it's a cool demo. So this was actually the second time I worked with Genu upstairs there. The demo you saw before, I did the vocals in Vocaloid, and I sent it to Genio, and he did the whole jazz piano. And this was the second time we worked together. Initially, I didn't really have a concept or anything for this demo. Just worked a little bit on some visuals. But then Gino came in with the music. We couldn't really decide on if it should have vocals or anything. And I think I told them to just do the lyrics in Japanese to fit the theme, and nobody would understand it anyway. But then he got the brilliant idea of asking Teresa, his daughter, to sing the vocals, and that's the vocals you hear on the demo. So this was the first big production. It's not really that complex or anything, but it was just the first one where we really stopped and tried to think on concept and how things flow and everything. Before that was just more trying to finish something and make a quick demo. This was more thought put into it. And we also started to move away from automaton because while it's a great tool, it doesn't really gel with Cable's workflow because every time you save an automaton change, it saves JSON to your clipboard that then you have to paste in another hop to feed it back into automaton. So it's every time you want to save, you have to do a tricky process, and it leads to a lot of errors and lost stuff. So we started to move away from automaton in this demo. And we started to explore again the built-in solutions in Cables. We didn't go to the timeline, but we saw discussion in their Discord of people using basically map ranges to do all their animations. So you have your current time of the demo that's playing, and you say from 200 seconds to 205 seconds, then X is going from 2 to 4. And you build all your animations with this interval range mapping. You can see here below a screenshot of our camera animations. And this was actually Genio's directorial debut because I couldn't really have the time or the creativity to do a lot of the camera movements. So Genio quickly learned Cables, picked it up, and was able to animate a lot of the cameras himself without previous Cables knowledge, as far as I'm aware. So even if Genio can learn it, anyone can. That's what I'm saying. And this is the final screen that you weren't able to show, but just to mention that this was AI generated, so we don't draw that well. Okay, final one, please. Let this one play.
I hope it plays.
old trance mix.
Let's have some old trance.
Yeah, so that was our latest demo made in Cables. It was a big undertaking. It was, I think, 3 weeks before revision deadline we started, right?
It was about 3 weeks, yeah.
About 3 weeks.
3.5 weeks, and we almost killed ourselves.
Yeah, at first it was me and Genio. We had some ideas, but we didn't have much, and so we brought in Mr. liqube here to help initially with the music, right? But at some point it just became basically the director of the demo, pretty much. So yeah, it's 8 minutes of soundtrack. So it's a bit crazy to do 3 weeks before the demo party, but
I have to say about the soundtrack that it had the oddest meter. It's like I don't remember exactly because sorry, I don't want to have this in my mind anymore. It was 13/8.
15/8.
15/8. Okay.
Yeah, and it's totally normal. Tubular Bell has that time signature, really.
Yeah, of course, it's great. Yeah. And then it switches to 4/4 and it switches back to 15/8. So it was.
Well, that's not my fault.
Yeah, no, I'm not saying. I'm just. Well,
So,
it was crazy to produce the whole thing and the sound effects and like making everything.
yeah,
fit
so
and-
we decided to also focus on a design first approach. So basically, concern ourselves more with making the demo look as pretty as possible, and not really trying to do any technical achievement or do stuff that if we could find a way to simplify and make it pretty, we would do that instead of trying to do everything.
But here's the funny thing, though. Here's the funny thing. We actually, I think, for what it's worth in Cables, we have achieved a bunch of technical achievements with the whole thing. Like we're going to get to this now. Like a system, for example, Cables is completely based on a timeline that is time-based. So if you have music that you want to synchronize to, like beat-based and the measures of like whatever, yeah, tempo, time signature, it's not possible. So we had to create a system that can create like immense amounts of triggers. Like each hit, like everything, we wanted to have like certain snares and certain kick drums and certain elements, like even like the rhythm of the whole thing on different outputs in operations in Cables. So like these outputs would light up exactly in the perfect moment, and this is not a good way to show it, but it's best.
We have screenshots and stuff.
Yeah, it's best to download it and watch it on a good PC because, or any computer actually. It's web-based with a good graphics card because it's really accurate. Like this timing system we created, Anticore is going to go into that. It just changed the whole thing. Everything is synchronized. Everything.
Yeah, so basically, since it's such a rhythmically complex soundtrack, we wanted to really nail the syncing, and we couldn't really do it with the solutions we used before, nor Automaton, nor the map range craziness. And so we started working on the dope sheet, which is, I can show it here. It looks a bit like this. So you see there on the left side is basically how we create all our timing for this demo. So what the dope sheet is a custom op. I can show it here, 1 second. I will go into the demo project, if that's possible.
While this opens, I'm just gonna explain that I did show control systems in the past. So and one part of the system was creating synchronized events. So when you have like different, in this case, different outputs where you want a value to go to another value, then you can slowly like transition to that value in a linear way. But now if you want that to be like more like an easing function, like you have on the phone, you swipe left and then it's like, it doesn't go like this. It goes like, whoop. And this is an easing function. So we had like different easing functions that we could transition any value to any value and create some sort of pseudo interpolation and do that for each value on each output individually in a different way.
Yeah. So basically, it's this custom op here. You can create any number of them in your patch. You pass it a time value. Here we have this variable that contains the current beat of the music. So this is calculated using the BPM and the
You
time
see at
signature.
the bottom there, it's the, down here you can see this is the beat of the running music.
Yeah.
So we just calculate in absolute quarter beats from the start till the end, regardless of time signature, because it was too complex.
And then
And-
this custom, sorry?
Yeah, and we, well, you see also the dope sheet itself, the operation. It has 8 analog outputs, that's the green ones, and you have 4 digital outputs, those are triggers. So we can say on-off, and the other ones have an actual value that is like transitioning or jumping or whatever.
Yeah. So with these 8 numeric basically outputs and these 4 triggers, we create our sheet. And so basically this is just like you see in a music tracker, basically a sync tracker text-based. So we created this syntax to program it with. So when the line starts with the symbol, it's a comment. But actually, any invalid line can be a comment. The line just gets ignored. But we use this sort of convention. This is just for our sanity because we, at some point, we had, I don't know how many we have here, I can check. But we have a lot of dope sheets. You can see here. This is all the dope sheets we created in this demo to coordinate the different objects or different scenes or whatever. And so it got a little tricky to understand what value did which, so we had to add these comments everywhere. And then this line here, we say for output A1, so the first analogic output, when the time is, or when the beat is 246.7, our value is 0. And this here, the blocks with the parentheses are the output values. So in A1, I want the value 0 at 246, and then whatever comes next is the easing curve to the next value. So S, I think it's smooth step, right? If I remember
It's
correctly.
smooth, it's smooth.
Yeah,
It's a smooth transition to the next value, which means it will transition from beat 246.7 to 270 from 0 to 3 in a smooth easing function, right? So,
Yeah.
but there are 2 ways actually I have to add. There are 2 ways to write this sheet. First, we had like all the outputs in one line. So we could have like multiple outputs on one line.
Oh, sorry.
It's okay. We can have multiple outputs on one line. And say, for example, output 1, 2, 3, they all, maybe you find one.
Yeah, I'm looking for one with position,
That is
camera
more
maybe.
complex.
This one must have.
Yeah.
Well, I can just show it, but basically,
Yeah.
if you have A1 here, but you want, like, for example, XYZ for your camera, you don't have to do A1 and then A2 and then A3.
Yeah, you can combine multiple outputs, and this label that says A1 or A2, it's just an offset. So everything that comes in that line, the values, they will start at, say, A1. And you can do X, Y, Z in one line, but you can also do, for the sake of readability, because it got really complex, you know, like trying to figure out which value moves to which value when you have all 8 of them in one line. You could just like split them up like this for more simpler stuff, and you could like even like literally write the values in by hand if you know the beats.
Yeah.
Then all you need to know is the offset of what you're synchronizing to, and then you just put an oscilloscope down there and see what comes out, and that's it.
So like this, I'm actually setting values for
Right.
A1, A2, A3 altogether, and then it just passes down to A1, A2, A3 also.
Yeah,
And
so
then, for example,
this means up here at 450, because we have an offset of A1, and A1 equals to this analog output, we're going to have A1, 2, and 3 transitioning to the next 3 values with different easing functions, completely different in one go.
and
It all
also,
runs in
if
the
I
background.
wanted to add another step on the animation here, for example, and I wanted to animate the X and Z values, but I wanted to skip the Y because I already have that animation from 50 to 56. So I just do this, and it just skips this port, and I can animate the other ones however I want. So
it
here,
would just skip the middle step and transition to the next known value, which is super easy. it seems a bit complicated, but once you get used to it, you're so fast with like changing like angles or effects or like create like the ending scene, the credit scene of this demo. We have a lot of text animation. Like for example, the easing when the names, the handles just drop down. It's like the swipe easing function, like on a phone, and then the names fade in and stuff. Like everything is automated through exactly this dope sheet.
Yeah, so basically that list of functions that PS showed in his seminar is basically what we implemented here with these codes for the easing functions that can transition the values. So here I can also show I'll show this, which is, you can talk about it.
Yeah, we had to like create some sort of a system that how would you even have all these cue points? Like how would you synchronize to stuff? So the solution was to use Reaper. Like I used the soundtrack that I made, and I would go. I have, for reference, the saxophone. I have the notes up there transcribed, so I know exactly to the millisecond where they are. And I would create like a ton of cues, and each cue would have a label, so you could give it a name. So this one is like a main kick, or like it has a kick plus something else. So we basically have that. Maybe show the next one.
Yeah.
And this is how many we had. We had like I think like 400 or so for the whole demo. We could export this. We could export this thing through a PHP-based exporter that reads basically the cues and turns it into like a complete list of stuff with comments. And the comments, they look like this then. So like it says underwater scene 5100. That's the time in the project, the measures and beats in the project. This is just for reference that we know what this is, and so we could copy and paste out of this export anything we want. And we even had like things in the script that would detect, okay, there's snare in the label, there is kick in the label, and it would automatically like route it already to the correct output. So we would just have copy paste.
Yeah.
We copy paste the thing in, and we have
basically
like
in
kick,
that
snare, and something else on 3 outputs automatically, just based on a text label.
So in that scene with the spheres and the text floating up, so basically that is synced to every note of the lead instrument, and Tom here in the Reaper marked every word with a marker, and then ran that script that exported the list of the timings, and then we dropped that into the dope sheet, and we had the timings already there, and we just assigned the values. So with really this demo was a lot about finding collaboration tools, like different collaboration streaming tools, audio streaming tools, ways to pass files around, ways to build these dope sheets, and really Cables really lets you manipulate it to add any behavior you want to it, so you can really adapt it to your own workflow, whatever you need. And here is, this is a screenshot of, I think, maybe like 50% of all of the textures we used in just for the texts and stuff. Every text you see in the demo is a texture, right? Mostly. It's
everything you see text-wise is a texture, because you could do it in Cables, rendering the text and everything, but I wasn't happy with the typography, the kerning, and like it didn't look good. So the best solution was also to create this much content, which is kind of like, the cryptic call is a poem I wrote. So it's based around that poem. And that's, when you look at it at home again, you read, there's also a poem you can download as a text file. So it had to have a lot of like content. And to make this look good, it was done in Photoshop as transparent PNG. And you could basically use that as a texture. But getting that in was a bit tricky. Yeah. There's so much more we can talk about this, but it's not going to fit here.
But even like the kerning of each individual letter was made very carefully.
Yeah.
And also here is an example of how we worked. A lot of time through voice chat. Mostly Tom was in the voice chat and I was by text, which got a little crazy at times.
That was funny. I just had like a solo chat. He was just chatting to himself.
Yes.
And responding to what I said in voice. So.
But here is a screenshot of Tom using a screen drawing tool to show me his ideas of how to animate a certain part that then we build out with the dope sheet. So this is sometimes I leave my computer, come back and find this stuff.
That was actually quite funny because we had this collaboration system. I had just a Chromebook standing there in front of my computer, and it was just constantly tuned into his feed. So his feed, he was not there working, then well, it was not doing anything. But I woke up in the morning and I got to the computer, and on that feed was already him working, so I could already like tune in and like watch him what he's doing. And so it was like a very kind of like it was a workflow kind of solution to get this done in a very short time.
Yeah.
And we actually got to the point of anxiety to like work on this because it was an insane push.
Yeah. Like 2-3 hours sleep every day for me.
Yeah.
But, yeah.
2-3 hours for like 3 weeks sleep a day.
I think we're almost out of time, but yeah, that was it. I was hoping to give a talk to show how Cables is very easy to learn and to pick up. It has an helpful community that you can join the Discord, ask your questions. You can find me around here, ask everything you want. It's great for...
Yeah, one big thing. We've decided that today we're going to make this this project open, completely open source, so you can get into Cables. You'll find this there, and you will be able to look at all the details that we worked out. You can use the dope sheet, and there's so much more like to say about this demo, about the individual techie things that we created, that we probably need 4 more hours. But it was just fun, like to come up with new stuff and synchronize everything. And I think we bit off a bit too much with this thing. But we do hope that you liked it, because watch it again, please watch it again.
Yeah. And yeah, it's a great prototype tool. You can quickly, if you do shader coding, you could quickly use it to start doing shaders there and iterate over that, do more complex stuff. You can also prototype texture generation. All that stuff is very easy to do in Cables. It's a battle-tested demo engine, not only these demos we showed here, but also other demo groups that use this tool much better than I and we do. And you can basically extend Cables to do whatever you want, because at the end of the day you have access to whatever the browser does, and you can fully customize it to your needs. Does anyone have any questions we can answer?
Was it too much? Was it too intimidating? You can really ask. No?
Why 8 minutes?
Because we can. Because first of all, the problem was... Yeah, but like if we made it 3 minutes, the demo, it would have taken the same amount of time, because we had to like create all of this stuff. So 8 minutes because the poem, I already had to cut down the poem because it was too much text. But I didn't want to get rid of the rest. I thought people can watch it again and appreciate the content. But it was just the pacing was not right. It felt like really crammed. Everything we wanted to do. And especially the ending was like an extra, 2 minutes or so. But the ending was so cute because it was missing the point of the cryptic call. What is the cryptic call? So this whole like floating into space kind of thing, and like saying basically, essentially, that we're like sort of a family, that life is short, that we should make use of it in that sense and do cool stuff. So that's in there, and that needed this ending. And then working out the credits. The credits itself is kind of like when people think it's over, the vases come flying in, and so I was like, yes, let's do it. Also, I have to say, Gino up there, he played a beautiful piano part, and I did this R&B version on top of it, so we're like, this needs to be used. It's kind of missing it. So yeah, that's why.
Thank you.